Nowadays, a terminology named lung-capacity is drawing more and more public attention. It seems that everybody acknowledged a very close relationship between lung capacity and health. But, in fact, do you really know what is the lung capacity? And why is this terminology connected with our health and life? Today, we're going to do a very simple experiment to examine how larger a person's lung will be.
My graphs show that lung capacity differs because of different body sizes. Another study conducted by Hibbert showed gender differences in lung growth and lung capacity. Besides that, Dr. Xia Jun has researched the effect of aerobic fitness training on respiratory function of university students. The results show that during aerobic exercise, the frequency of breathing runs faster and the depth of breathing increases. It causes the respiratory muscles to exercise and become more powerful. Even when quiet, the breathing will deepen and the number of times will decrease. Since we have already known the relationship between aerobic exercise and respiratory function, you may want to know whether exercise, especially aerobic exercise, can increase lung capacity.
In the experiment, we find 20 students. The questionnaire is used to collect some basic information of our participants, such as age, gender, and exercise frequency and time. We use balloons to collect participants' vital and tidal capacity, since some scientists have reported that some variables related to lung capacity are associated with height and weight. To make the data more comparable among different people, we use body mass index to describe their body sizes and show the correlation between tidal and vital capacity. Main materials needed in the experiment are round balloons and rulers. First, participants filled the questionnaires and were interviewed. Do you know some basic knowledge about lung capacity?
Volume of the air that your lung can hold as you breathe.
I know a little. No.
Do you think exercise can increase your lung capacity?
Yeah, of course.
Maybe yes. Someone do some exercise can build up his body, and maybe build up his body can increase his lung capacity.
Maybe.
How do you feel about the statement that larger lung capacity, stronger body?
I think it should be right.
Well, I pretty agree with that.
Then we had every participant blow a balloon with a deep breath to measure the vital capacity, which is basically how much air your lungs can push out in one breath. After that, participants were asked to blow a balloon with a normal breath for knowing about the tidal capacity. Third, we used two rulers to measure the diameters of the blown balloons and wrote down the statistics. The participants who were in the group of non-athletes were asked to do more exercise for the next 2 weeks. After 2 weeks, we interviewed them for getting some information. Then the second and the third steps of the experiment were done again to collect one more group of statistics of these non-athletes. After sorting out all the data and the information we have gotten now, we can start to analyze.
We invited 20 participants in total, which consists of 10 males and 10 females, of which 10 of them are athletes and 10 of them are non-athletes. When considering athletes and non-athletes, athletes generally have larger tidal capacity than non-athletes, and same goes for vital capacity. Besides, BMI is in the range of 21 to 25 in the athlete group, while in non-athlete group, the range is from 20 to 24. Then we consider gender difference. Males generally have larger tidal and vital capacity than females, which is the same as other scientists reported. For BMI, males range from 20 to 25, while females range from 20 to 22. Besides, we found out that the relationship between vital and tidal capacity among athletes is much weaker than that among non-athletes. Things are similar for the relationship between BMI and tidal capacity, but athlete group has stronger relationship between BMI and vital capacity than non-athlete group. These relationships give some information that is beyond our expectation. However, on the other hand, these unexpected findings may suggest that for athlete people, tidal capacity may not depend on body size, while vital capacity does. But you may still wonder, what do I mean by saying these confusing words? Well, what you need to know is that vital capacity consists of three parts, one of which is tidal capacity. Some scientists have reported that vital capacity is related to one's height and tidal capacity is related to one's weight. Since we found that vital capacity is related to one's weight too, I will explain to you how exercise can increase one's vital capacity. There is no denying that long-term exercise can bring you more muscles. Muscles have higher density than fat. That's why an athlete usually have higher BMI than a common person in same height. Therefore, exercise increases your muscle mass first, and then more muscles require larger vital capacity in order to support yourself when you are doing exercise.
In conclusion, our whole project is divided in 4 parts. First, the aim of our project is to find out the relationship between lung capacity and exercise. Based on this question, we made our own hypothesis, which is a positive correlation. After reviewing the existing method and theory, we made a very simple experiment that asked people to blow a balloon. Finally, the results suggested that for athlete people, tidal capacity may not depend on body size while vital capacity does.